Hey everyone, today we're going to explore composite solids. So composite solids are just solids that are made up of two or more basic solids. So they're more complicated shapes. And when we see complicated shapes, we can just cut them up or dissect them into easier shapes so that we can calculate the volume and total surface area, if that's what we need to do. Okay, so let's take a look at example 11 from the book. It tells us that the figure below shows a cross-section of a tunnel. Remember, cross-section just means that we're slicing into that tunnel, okay? The tunnel originally looks like this, right? It's a very long tunnel, and they're basically taking a slice of it out, kind of like if you were to cut into a loaf of bread and you just look at one slice of it, then it would just look like that, okay? And then this tunnel is basically a trapezoid, CDEF, put on top of, surmounted on, a rectangle called ABCF. And then together they make this composite shape, this solid. Okay, and then they're giving you all the measurements. The only thing that is not shown is this information right here. The length of the tunnel is 130 meters, right? Because we don't see that because they're just showing us a slice of it. But in actuality, the length of the tunnel is 130 meters. Okay, so go ahead and pause the video and see if you can find the perimeter of the cross-section, the area of the cross-section, the lateral surface area, which actually is just the rectangle parts, okay, of the surface area, and the volume of the tunnel. Okay, let us see if you did everything well. So let me just write down what I can't see here because I scrolled down. The length of the tunnel is 130 meters. Okay, tunnel length equals 130 meters. All right, so back to the perimeter. Remember, perimeter of this cross section just means adding up all the sides. Okay, so we're gonna do that. Perimeter equals 2.5 meters plus 3.6 meters plus 2.5 meters plus 2.6 meters plus 5 meters, and then we have one more missing here. They don't label it, but it should be the same as the other side, which is 2.6 meters. Okay, and then we're going to put that into our calculator so that we can figure out the total perimeter or the borders. 2.6 plus 5 plus 2.6. That's 18.8 meters. Let me just double check that because I think I did that really quickly. Plus 5 plus 2.6. Yeah, 18.8. I would hate to get an addition problem wrong. And this is just meters because we're just adding the meters together. So instead of shorter meters, it just becomes a longer meter answer. So there's no squared or cubed. I'm going to put this answer on the side here because in the past I have, erased answers and then I wished I hadn't because I need it later on in a calculation. So I'm going to keep that there in case I need it for something else. And I'm going to erase the space so I have more room to write. Okay, now we're going to talk about the area of the cross section. So the area would mean that I need to figure out everything, all the space that's in this shape. Now remember, this is a composite shape, so it's made up of two more basic shapes, right? It is made up of a trapezoid and it is made up of a rectangle. So we're going to figure out those two areas and then we're going to add them together. Okay, so we're going to start off first with our trapezoid. So the total area is going to be the area of the trapezoid plus the area of the rectangle. But like I said, we're first going to calculate the area of our trapezoid, and that's going to be B1 plus B2, both my bases added together, divide by 2, times the height, little h, of our trapezoid. Then we're going to add it to our area of the rectangle, which is just length times width. Okay? So two different formulas going on. All right, let me see if I can color code this well. So my trapezoid stuff will be in this dark blue. First base plus my second base. Do I have one of them covered up here? No, oh, it's just this one down here, right? Since they didn't show me the base here, it would be 5 because this length should be the same as this length. So base 1 is 5 plus base 2, which is 3.6, divide by 2. After that, you're going to take that answer and multiply by the height of the trapezoid. Height of the trapezoid, remember height is straight up and down, is 2.4. Okay, and then after that, we have the length times width for our rectangle. The length is 5, and then the width is 2.6. It doesn't matter if you switch them, you're still going to get the same answer. Okay, so let's actually calculate this and get the answer. So we have in our calculator 5 plus 3.6, then divide that by 2, because according to PEMDAS, you got to do what's inside the parentheses first. And then you can take that answer and multiply by 2.4. So then you get 10.32. Okay, plus, we're not going to add yet. We still have this multiplication to solve, because according to PEMDAS, we got to do that first. We have to add at the very end, unless it's inside our parentheses, then that goes first. Plus 13 is that answer. So we add at the very end 23.32. This is area, so it's going to be meters squared. That's the area of the trapezoid. I'm going to write that down over here in case I need it later. Okay? And then we're going to answer C, which is asking us for the lateral surface area of the tunnel. So remember, lateral surface area just means the rectangle parts. Okay? So I just want the rectangle parts. Now, how can I do that, right? Well, if I want just the rectangle parts, then I'm going to have to figure out the total surface area, but basically just ignore the base parts, okay? So the surface area formula is perimeter of the base. Good thing I have that up there so that I don't have to do that later, times the height, big H, of the entire prism, this one right here, plus 2 times the area of each of those bases, which is the trapezoids. We have that as well, but again, we don't care about this area. They just wanted the lateral surface area, so just the rectangles. Well, lucky for us, this part of the surface area formula is just the rectangles area. And then this part is the bases area. And again, we don't want this because they didn't ask that. They just wanted the rectangles. So we just need to do perimeter of the base times the height of the entire prism. We already have the perimeter of the base. We have to just take that number and multiply by this height, the height of the prism. Remember, because this is sideways, right? We had to put it upright, and then this would be the height. What is this height? They don't give us this number because it wasn't in the diagram, but it's this. The tunnel length is that big H, okay, because it's sideways, so it would actually be the tunnel's length that is the height. Sometimes they will trick you and put your prism sideways. Okay, so again, your lateral surface area would be the perimeter of your base times big H. And again, they gave that to us because that's that 130. And then we have the perimeter calculation from before. Okay, so we're just putting into our calculator 18.8 times 130, 2,444. Meters times meters, meters squared. Also, we know it's meters squared because it's surface area. Okay, so that's the answer for C. Now we need to figure out the volume of the tunnel. The volume of the tunnel. So let's see. We can erase this because that was just the surface area. That's not going to help us with volume. They're talking about two different things. Let's see, volume, the general formula for volume, trying to remember, is area of the base. And right here, our base is a trapezoid. Area of the base times the big H, height of the entire prism. So that would be 23.32 meters squared times big H, which is the height of the prism at 130 meters. Put that into my calculator. I got 23.32 times 130, 3,031.6. 3,031.6 meters squared times another meters is meters cubed for my volume. So keep those calculations, they're going to come in handy. They're all kind of related to each other, right? Okay, one more example from the book. Example 12. The figure shows a prism whose cross-section is formed by cutting out the trapezoid DCGE. So there's an invisible trapezoid here that they cut out, and you'll probably see that because of the dotted lines. So the trapezoid actually doesn't exist, but they're thinking, this is a weird shape, right? We can all agree this is a weird shape. But if they think about it as a parallelogram originally, I'll draw that out here. You can imagine it as originally being a parallelogram, but we cut out a trapezoid to make this current weird shape, then it makes your life a little bit easier, right? Then it's just like a subtraction problem. So they want to know the volume of this prism. So we're going to use that strategy. We're going to pretend like it's a trapezoid with the, a parallelogram with a trapezoid cut out. And we need to find the volume. Okay, so let's start off first with the volume formula. Volume formula says that it is the area of the base times the height of the entire prism. Okay, so we need to take the volume of the trapezoid, just draw a quick sketch of my trapezoid, minus the volume of, volume of the trapezoid subtracted from the volume of the parallelogram, right? Because it was taken out here to create this crazy shape. So let's do that. If we're just looking at the volume of this entire parallelogram, this one right here, then we're looking at the area of the base. The base is a parallelogram. A parallelogram's formula is base times height. And then we're going to take that and multiply by the height of the prism, which is 12. Okay, so we're going to do that. Then we're going to subtract the volume of this trapezoid here. And the trapezoid, that area of the base, if you remember, because we've covered it a couple of times now, is base 1 plus base 2 divided by 2 times your height, little h, but remember you still have to multiply by a big H. Lots of H's. So now let's plug in those numbers. Okay, so we have base times height for the parallelogram. So the base is 15. The height of this parallelogram, just straight up and down, is going to be this. 5 plus 5, which is 10. Times the big H, the height of the entire prism, which is 12. Okay, that's all together. I'm going to put that in brackets. They are together. And then we are going to subtract the trapezoid stuff. Trapezoid stuff is base 1 plus base 2. I have one base, which is 5. What's my other base? What's this measurement here? Well, I know the other side is 6, and this entire measurement across is 15. Oh, so this one must be 9. 6 plus 9 is 15 all the way across. So that other base is 9, divide by 2, times the height of the trapezoid, because that's a little h. So just the height for the trapezoid, would be one of these guys, right? Because the trapezoid only goes like halfway. So times 5, and then the height of the entire prism is not this up here, right? Because this prism is sideways, so it would be 12. Just like how this big H is 12. All right, we got a lot of numbers to crank. 15 times 10 is 150. 150 times 12 is 1800. We're going to subtract whatever this whole mess is. 5 plus 9 is 14. 14 divided by 2 is 7. 7 times 5 is 35. Times my 12 is 420. So my answer is going to be that difference. 1800 minus 420 is 1,380. 1,380, this is the volume, so it's going to be centimeters cubed. That's our volume. So even if they give you a crazy weird shape like this, you can either, like the previous problem, put two shapes together, like your trapezoid plus your rectangle, or like in this problem, you can take away a shape. You can be like, okay, this is a strange shape, but it's basically this parallelogram minus a trapezoid that got us to this strange shape. So you can either add up to your composite solid, or you can subtract and cut down and carve into your composite solid.